Technologies Technical Services Manager. Today's agenda, we'll have a quick overview of mallet technology. We'll have the webinar, how to use SpaceClaim scripting to parameterize your models. After that, we'll also have time for discussion and questions. There is a question panel in the GoToWebinar control panel. Please feel free to type your questions in there at any time. We'll also have time at the end if you'd like to ask a question directly. Also, this is being recorded, and this recording will be available at the Mallet website shortly after today's webinar. The mission statement of Mallet Technology: we use world-class engineering software tools combined with our broad knowledge and expertise to help our clients compete in today's marketplace and produce reliable and cost-effective products. We've been serving engineering customers for over 40 years. Our primary office locations are Durham, North Carolina, and Cleveland. We also do ANSYS consulting services in all types of physics, including structural, fluid dynamics, and electromagnetics, both high and low frequency, including time. We do ANSYS training at our Mallet locations or at a customer location. We handle ANSYS software sales in the states of Maryland, Virginia, North and South Carolina. We've been an ANSYS channel partner since 1985. Other companies we have strategic partnerships with are Ozen Engineering, which is located in California and Silicon Valley, and CAD-FAM America, which is located in the Detroit area in the Midwest. You can visit us at www.mallet.com. Upcoming activities, our next webinar will be Friday, October 11th. The subject will be a CFD subject, which is using overset message meshing in ANSYS Fluent. You can register for that at www.mallet.com. So having said that, again, welcome. Steve is going to give our presentation today. And like I said before, you can type questions into the panel, or you can ask questions at the end. Everyone's muted. We'll allow you to unmute yourself at the end of the presentation. So with that, Steve, go ahead and start the presentation on ANSYS SpaceClaim.
Sorry, can you give me control? Got it. Okay. Okay, so yeah, as Buzz mentioned, today we're just going to talk about kind of SpaceClaim scripting. We're going to go over the basics. What is it? How do you use it? Kind of what are some different features to be aware of? And then how can it be leveraged for parameterization? So just to preface this webinar, this does involve coding. The language is IronPython. I can say from experience that you do not need to know this language to kind of pick it up and work with it. SpaceClaim provides a number of examples that I'll kind of touch on that can bring you up to speed pretty easily to make it a functional tool. So first and foremost, what is SpaceClaim scripting? So SpaceClaim scripting, it's a feature built into the SpaceClaim GUI. I think about it similarly to if anyone kind of worked with the old ANSYS Mechanical APDL, and as you generated CAD in ANSYS Mechanical APDL, it would generate a corresponding text file of all the various commands used to generate said CAD. I see SpaceClaim scripting as mildly similar to that, right? It's a avenue through which you can create and modify CAD, create name selections, and do any number of other operations to kind of set up an analysis for parameterization and interfacing with mechanical. So the SpaceClaim scripting tool, it allows for, I see as three primary things. The first and foremost is kind of creation of CAD through scripting. The reason this is valuable over just, let's say, standard CAD creation and your indirect modelers like Creo or SolidWorks and or a direct model like SpaceClaim just via the extrude tools and just a very object-oriented interface. The benefit of the scripting method is it's very repeatable. If you want to create essentially the exact same CAD and while you're creating it, modify different um, dimensions or parameters, uh, it's all available and directly shown in the script that's created, right, or in the code that's created, because all explicitly has to be called out. Versus it may not be quite as clear as how to do it when you're doing kind of the indirect or direct modeling directly. So the next benefit is you can use this to partially or fully parameterize CAD geometry, depending on your needs. And then finally, if you do decide to create a parameterized model in SpaceClaim, um, the largest benefit, as I see it, is essentially you can create a very robust link between SpaceClaim and mechanical, where essentially you can recreate your geometry, kind of deleting everything, recreating it all with changing variables for different things, and still maintain all your links between SpaceClaim and mechanical and not have to relink everything. And I'll kind of talk about how SpaceClaim does that. So next question is, when should I consider using it? So when should I consider using SpaceClaim scripting? In all honesty, it's not a cut and dry decision. I think the first criteria would be, is there a need to run parametric design studies and or a need to run analyses on kind of similar geometry over a range of cases, right? That could be a reason to look into SpaceClaim scripting. When I've used it, it's been when I've had cases where essentially the CAD geometry is similar enough that I can use the same script to create the geometry every time. However, I'm going to kind of grossly modify the overall dimensions and maybe the response of the geometry I create. And then I may use SpaceClaim scripting to handle that operation, but then have it linked to mechanical without breaking any links or interfering with any of my loading conditions. So I will note here, from the parameterization perspective, SpaceClaim does overlap some with Design Explorer in terms of its features, and it can actually act with Design Explorer where you can specify parameters that are actually script parameters and have it interact with Design Explorer, varying those as well. So generally, I would look at Design Explorer for kind of relatively straightforward and simple parameterization studies, and then I might kind of switch over to SpaceClaim scripting for kind of more advanced and global studies where you're changing many different things and trying to maintain connectivity well and potentially not having super consistent geometry for different problems. It just depends. So I guess my recommendation here would be try it, get a sense of how it works, and then if you get into this position where you have this parameterization need, ask yourself, how advanced is the need? Can it be done simply through Design Explorer, or do I want something more advanced where I have more control over the CAD? Okay, so that's kind of all the upfront stuff. I'm about to get into the meat of it, and this is going to be a very kind of first pass, surface level look at SpaceClaim scripting. I won't go into any super technical details. So the first question is, how can I access the SpaceClaim script editor? So it's very straightforward, right? If you just go to the File menu, File, New, Script will open the script editor. And then I'll touch on kind of where to go from there. And then the final question, I know I already mentioned this, but I just want to kind of minimize anyone's concern that you do not necessarily need to know Python or IronPython to be able to use the scripting tool. There are plenty of features in the tool to kind of help you learn how to interact with it. And I'm going to show those later in this webinar. Okay, so real quick, let me just open SpaceClaim. So if I start, let's just say I start from scratch with a base level SpaceClaim. It's going to open with a standard opening where you're not going to have the script editor available to you. So this is the kind of default way SpaceClaim opens. If I want to view the script editor, I can just either one, I can open a script, or I can just go to File, New, Script. It's going to open the script editor on the right side of my screen, and this is the editor, and this is kind of how it interacts with the rest of the system. So before proceeding, I wanted to first touch on kind of the top toolbar and the different features here, right? So you have your basic open, save as tools. There's a couple tools here that are important to know. The first is the scripting tool does have a record button. So essentially, if I was to go ahead and create some geometry, let's say I'm just going to create a rectangular block. My record button is active. So I'll do 20 millimeters or 20 millimeters, right? It tracked all that information. I'm going to close out of here, extrude this so I have a perfect block. And you can see as I'm kind of moving through the script editor, it's creating the different features that I'm adding. So if I wanted to, in a second, I actually will be able to go back into the script and just hit run to recreate this geometry. You can see as I keep going through, it's just making more and more script or code that correlates with what I just created. Right, so let's say I save this script. Okay, so now I have a new script that will allow for this geometry to be automatically created. If I want to, let's say, recreate it, I could just go ahead and delete it. And my record button is still on, so it recorded that delete. But all I need to do is hit run, and now I have my geometry back. Right, but what you can see here, and this is the benefit of having the code kind of available to you, is every little dimension that went into creating this geometry, whether it be square that was extruded or later on the rounds, right? These are all exposed, right? This round was 1.41 millimeters. If I wanted to modify that, I could. If I wanted to modify the overall dimensions of the original square, I could do that as well. I can create, just like any other kind of scripting, I can create my own variables. Let's say I say test equals 1, and I can say, equals 2, top equals test plus bottom, right? I can create variables that I then leverage later in the CAD. So for instance, let's say I wanted, I'm not going to modify this on the fly, but I could at least say here, let's say I want this to be whatever the resultant top is. That will change the overall dimension of how this thing is created. And I'll try to run this. This is not tested, so I don't actually know if it'll work. Yeah. But that kind of is the power of the scripting interface. So that showed you kind of the record button functionality. I will note here, the record button works much of the time, but it does not work for every single feature in SpaceClaim. There are times where you may be required to kind of dig a little deeper to figure out what code is needed to get a specific action accomplished. And then from a top level best practice, I've found in using the SpaceClaim scripting, my most robust behavior generally comes when I'm set in under the record dropdown verbose mode, as well as index mode. And essentially the difference between, really I'm going to talk about smart variable and index. Index will specifically call out in the code the index associated with a given part, whereas smart variable will make a separate variable that defines that index. But I've kind of found that to be not as robust when I'm going and rerunning and changing things periodically. So just to clarify that. So if I look in my code here, This latter part of this code, this get root part dot bodies 0 dot faces 0, this is the index of this specific block. If I was to switch this, let's say I switch this to smart variable instead, and create a new feature, right? You're going to see that the code that's created is going to be slightly different. Oh, I need my record button on. One second. So I have my block, my record button is on, and I'm just going to create a new object with smart variable showing, right? And you can already see in the window below the behavior I'm talking about, where with smart variables, you're creating these face1, face2 variables that are pink, which are variables associated with the index of the given part. However, I've found that, one, for my ease of understanding the code I'm writing as well as robustness, I've generally found that using index is kind of my preferred option. But I'll obviously let you guys decide. You can use it however you would like. So continuing on with the toolbar. So we have our record button. We have insert selection, which just dictates how a selection is inserted into the script. And then on the right side, we have some debug tools, step over, step in, step out, and then our run button. By default, the run button, I believe, opens in, I want to say run mode. If you want to go into debug mode, then you would switch to debug accordingly. And so let me just talk about the debug mode a little bit. So the debug mode, if you ever worked with any other programming GUI editor, it's very similar. The SpaceClaim script editor is a very simplified version of like more complex editors, or for Python or let's say even MATLAB, for instance. But it's very similar. So if I have a very basic script here, this script is in no way interacting with geometry. It's just literally a script. I kind of establish a few variables. I do some mathematical operations on said variables. I run through a while loop, filling a list with some numbers, and then I end it, right? So if I want to debug this and try to get a sense of what's actually occurring in my script, all I need to do is enter debug mode, right? And then enter a spot in the script where I want to kind of run until I hit that spot. So if I hit play, it's going to execute the script until I reach my marker. Once it's there, it's going to stop. You can see here I've established A. If I hover over the variable, it shows me the value. A is equal to 1, B is equal to 2, and then if I continue with the script, I can see I'll do a sum operation, I'll get an average, and this average is incorrect because my math is wrong. So let's say, okay, I just identified that my average is wrong, so let me stop this. All I need to do to stop it is escape. I'll re-enter the script, continue on. Now my average is fixed. And then I can continue through the list, right, until completion, where you're going to see at the bottom I'm just printing my fill list, which is just what I'm doing in the while loop, and you can see it prints out in the editor or the interpreter box below. So all you really need to do to interact with the debug mode is you have your stop points, you have to set it in debug mode, and then the one other thing I will note is you don't necessarily need to always run from the top. If you are, let's say I wanted to change this from I equals I plus 1 to I equals I plus 3, but I don't necessarily want to rerun the whole script. I can always click on a line that I want to start running on, hit run next line, and it'll step right into that point without running any of the information before that point, right? And you can see here my new output is 0369 since it's I plus 3 instead of I plus 1. So that's the debug mode. So those are kind of the main features on this toolbar. You have your insight selection, your record button, your debug tool, and then your run tool. One thing to note is you can certainly always run in debug mode. However, as your script gets more and more complex, debug mode is inherently a slower way to kind of execute your script. So if you want a fast execution, particularly for complex scripts, certainly run it in run mode instead. Okay. So that was the toolbar. A couple basics just to note here. Any dimensions you define in SpaceClaim or the SpaceClaim scripting tool, they're always defined in meters, without question. There is some functionality where you can enter dimensions and other variables, and you just have to specify commands around those numbers to convert them accordingly, right? So for example, one conversion would be capital M for millimeters, and then inside would be the number you're converting from millimeters to meters, and then the same for inches. Okay. So the next part that's good to know for kind of interacting with the SpaceClaim scripting tool is understanding how to kind of access different parts and different features of different parts. So I just wanted to walk through this, and I'll show this pretty much this exact same example in a second in SpaceClaim itself. But the way that SpaceClaim defines or indexes bodies is essentially it's a top-down approach in the model structure tree. All bodies are indexed from 0. So your first body is always going to be index 0. And then it's going to proceed with increasing numbers by 1 for each next body. So you can see here I have body 0 for the first body, and I have body 0 for this, or body 5 for the 6th body, since I started indexing from 0. So that's how indexing works. Then the next part is how do you access the individual parts, right? So there's the first command snippet, get root part. Get root part pulls information from this top level, right? So if you ever have any bodies sitting in this top level of the tree, that's where get root part is referring to. If you want to go deeper into assemblies or sub-assemblies, right, then the code changes a little bit, right? So if I have a kind of top level assembly and I want to grab a part in this assembly, right, all I'm going to do is instead of just get root part dot body, it's going to be get root part dot components. Components is how they define assembly, hence why it's called a component in the structure tree. And then it's going to be the indice for the component. Once again, the index for components starts from 0. Dot content, and then the body you want to query. And then it's going to be something very similar if I have a subassembly, where instead of one component, now I have dot component, because essentially I'm stepping down through the feature tree. Dot content, dot bodies 2, right? And it's 2 because it's the third body, and the index starts from 0. And then last example, just to kind of drive home the point, here the index starts from 0 for the components. So here I'm going to have get root part dot components 1, since I have my first component, which is 0, and then I have my second component, which is 1. So this is kind of the script to grab different bodies in the SpaceClaim scripting tool. So let me show an example of this. So I essentially have the feature tree that I just showed in that slide actually in SpaceClaim. All right, so it's just a bunch of cylinders, nothing too riveting here. But you can see in the right-hand side of my scripting tool, I've created 5 different selections, right, using the code I just showed you. So if I run this script, that's going to run. It's not going to generate anything. But what I can do now is I can hover over the selection, and I'll identify what body is associated with each of those selections. So for get root part 0, or get root part dot body 0, my selection 1, you can see it's highlighting this top left blue cylinder. And then I can find that if I look in this feature tree, that corresponds with the cylinder it should, right? Same thing for selection 2. Selection 2, it's going to show the 6 body. This is the 6 body. And then onward and onward, right? We're going to find it essentially correlates with what I showed. So that's good to know, just to know how to query bodies. If you want to query a face or an edge on the body, then it just a little further, right? Then it's going to be dot faces. Let's say I just want 0 for selection 3. So now you can see selection 3 is no longer a body selection. Now it is a face selection. You can take this further. You could say maybe I want all the faces, right? So I'll just make that a colon instead. And then if I hover over selection 3, now it's going to select all the faces. You can see it's a count of 3 faces in the box that popped up. It's not actually selecting the whole body. And then I can take it even further. Let's say I want edges. Same thing. Edges, the index is always going to start from 0. Now I'm selecting the first edge, and then I could do the second edge and select the bottom circle, and on and on and on. The one thing I will note is as you are typing these selections, let's say I make a new one, there is built-in functionality in SpaceClaim to try to help you understand kind of what's available at each level of a given command, right? So here I'm going to say get root part. It's going to finish it for me. Then I'll go dot. You can see I have a dot box that popped up under the get root part command. There's all these other ones that can be queried that you can pick from. And so here I'm just going to go components. Let's go 0. Let's go 1. You can see once again I'm still getting all these options. And so let's say rather than going deeper, I just want to get all components under component 1, which there are none. So that would not be a great choice. So we're going to change this to 0, and then we're going to say get all components. So if I run line 6, you can see it's selecting one component under this, which is component 24, which if we look back at the feature tree corresponds with the one component under component 25, right? So you can essentially use that prompt to inform different operations if you're not quite sure how to get to where you want to get to. So for instance, if I did one more example, so I do get root part, dot bodies, 0 dot, and you can see here I can select edges, faces, I can get name, get visibility, etc., etc. Let's say get name. Let's see what occurs. So my selection here is solid. So I selected get root part body 0, so that's going to be the first one. Let's change the name to first solid. Right, it'll update accordingly. So that's just to give a good understanding of how the parts and the edges and the faces are indexed in the CAD itself, because I know it's oftentimes very important to know this to kind of select the according bodies that you wanted to and or assign the proper name selections. Okay. So next up, I want to talk about kind of how SpaceClaim and specifically the SpaceClaim scripting tool can be really helpful in establishing good interaction with mechanical. And when I say good interaction, I mean when we're kind of doing these parameterized studies and recreating the CAD or changing the CAD, how do we ensure that we don't break links as we go ahead and update mechanical? Because essentially we don't want to reassign boundary conditions or loading curves or anything like that every single time that we change the CAD. So in that case, I have a simple example here where essentially I have a cantilevered beam. I'm going to have the cantilevered beam, or not, sorry, it's not cantilevered, support on both ends. But it's going to be fixed support on one end, and then it's going to be a simply supported boundary condition on the other. And you can see this is just a surface body that I have created the script to walk through. And now what you can note is in the script, I've identified a few variables that I can update really at will. So I have beam length, beam width, and thickness. So here, if I wanted to modify thickness and rerun this, you're really not going to see much change outside of the fact that this just updated from 1 millimeter thick to 2 millimeters thick. However, I wanted to make a more noticeable change. I could come in here and rather than having this thing be 1 inch wide, I could say this is 2 inches wide, right? And then I'll rerun it and it updates automatically. And that's because in the script itself, I've called out these variables for the various commands that dictate the creation of the CAD. So that makes sense from a scripting perspective, but where it becomes valuable is in addition to kind of the CAD creation that I have in the script, what you can also see is I've created a number of name selections automatically in the script, and we can look under groups and verify that certainly there are name selections that have been created under groups. And so this is creating name selections based on the index of, in this case, an edge for the simply supported edge, or another edge for this fixed support, or let's say I'm going to have a pressure load on top. So then I'm going to have the load on a face, etc. Right? So this script automatically creates these name selections. So what I can see is if I go to mechanical, right? If all my name selections import just as they're defined in SpaceClaim, right? So I have an edge selection for fixed support, simply supported, mesh sizing, or actually, sorry, body for mesh sizing, and then a face for load sizing, or not load application. And then what I can do is I can also have all my boundary conditions. You can see here, it's called out with a name selection, calling the name selection that SpaceClaim created. Same thing for simply supported, same thing for the force load. As long as the name selections in SpaceClaim have the same name selections that were defined when, essentially, let's say this load was applied, no matter if they're deleted or removed, as long as when it updates, it can find a name selection that is named the same, it will relink without issue, right? One difference between SpaceClaim and mechanical is in mechanical, I can create additional name selections with the exact same name. Right now I have 2 load name selections. SpaceClaim does not allow that. So in SpaceClaim, if I was to try to create a new name selection called load, it would disallow it, right? Therefore, its assumption, mechanical's assumption is, as long as the name is the same, it's appropriate to use in the boundary conditions. So here you can see my geometry does not reflect what's shown in SpaceClaim. And this is a very simple example, but I can confirm that I've used this for significantly more complicated examples as well. So you can see this is now 2 inches wide instead of 1 inch wide. Here, if I just update the geometry, it's going to update. Everything will update except I will need to reassign a material for this just based on my user settings. So you can see all my name selections updated, my geometry updated, and then if I go ahead and solve this, keeping in mind the only thing I updated was the material for this given body, it will solve without issue, right? Because my loading and boundary conditions are unchanged. So that's really where SpaceClaim can become really powerful, because it allows you to kind of freely modify CAD however you want, as long as you're maintaining your name selections and still have mechanical update and run without issue, right? So for instance, if I wanted to put a hole into this beam, I could. It would run without issue, right? I could do any number of things, and it relatively well maintains the linkage between the 2 systems as long as your name selection is still relevant. Okay, so the last thing I wanted to touch on is example code snippets. So within SpaceClaim, as a tool to help new users kind of understand how to use it, SpaceClaim does have built-in command snippets that you can add and learn from. So this is also in the toolbar. It's essentially this parentheses, dot, 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 parentheses icon where it's an insert code snippet. So I click on this, I'm going to get a number of options. I can look at code snippets that are used for constructing geometry. I can look at code snippets for evaluating geometry. I can look at Python language constructs. Let's say I'm not familiar with the Python language. I can look at those to kind of learn how the constructs are put together. And then I can also look at how to read from files and how to walk the structure tree. So just for example, why don't we look at, we'll look at this example of building a pyramid of spheres. So you can see I'll insert this example. It'll create the script automatically. I can just go ahead and run this, right? And you can see now I have a pyramid of spheres that have been created. And while it may not be very helpful to have a pyramid of spheres for your given analysis, where it does become helpful is dissecting this code for exactly what's going on, right? And generally what I'll like to do in a case like this is I'll start with none of the CAD, and I'll step into the code at line 1, and step by step get an understanding of how this thing is being created, right? So I can see first there was initial ball created. I'm establishing some variables. I'm still establishing variables. It looks like I just copied a component, copying components. I could maybe hover over something if I wanted to see exactly what was going on. It looks like it's developing a list. And then I'm just going to run. I could run through the rest of this, and then it's going to get to a point where it generates it, right? So it's that slowly stepping through behavior that would allow me to kind of come to a great understanding of how this code works. And so just about to wrap up here, what I should note is, right, that's one example. But let's say I wasn't quite sure how to do a while loop or create a list, right? That gives me a list. I can look at how do I do a while loop in Python. This just shows me an example of a while loop in Python. And the list goes on. And so I would say in terms of if you either one, are not familiar with Python, or two, are not familiar with SpaceClaim scripting and the specific used to interact with the SpaceClaim interface, this is the place I would start, right? In terms of interacting with geometry, then I might look at constructing geometry, or maybe better would be evaluating geometry, right? And I can just pull up all this different example script to look at different cases that have already been created for me. All right, so if I wanted to look at how to create a spline, I could, right? I could run through this, and this made a helical spline curve, right? And I can kind of just go on and on through the list until I grasp how this code works. So that's pretty much wrapping up what I wanted to cover for SpaceClaim scripting. I know it was very top level. There's inherently it is a coding language, so there's only so much you can go through in 40 minutes. But really the primary purpose that I see for SpaceClaim scripting is really for parameterizing models when you're trying to do different design studies, or let's say we have a pump design that the same design is used for multiple different sizes of a pump, and you don't necessarily want to create many different analysis setups just because you have different CAD, right? This would allow you just to create the CAD every time using kind of the script you created once and just varying a couple parameters. It would relink everything mechanical, and then you could rerun it without issue. But it just takes a slight judgment call to figure out when to use it and when is it most beneficial. The one thing I did not touch on here that I didn't have time to is there is also a way to, I'll show it very briefly, under groups. There is a way to create a, let's see. I'll have to look it up. There's a way to create essentially parameters to use with Design Explorer. So Design Explorer will actually be updated based on the parameters you define um, here, right? You can create a script parameter that then you can query in the tool itself. And then this will link with Design Explorer, and you can edit that value from Design Explorer as well. So that pretty much wraps up what I wanted to cover. I know it kind of was a flurry of topics that spanned potentially all of SpaceClaim scripting, but hopefully it kind of gave you a good sense of what it's valuable for, what it's powerful for, and how it might be useful for your own means. Okay, so then with regards to questions, I do see
So
we
there is a
have,
question in the question pane there.
yeah, so it looks like we have two questions. The first would be, it's how do you select all the bodies within a given coordinate range? For example, between z coordinates, -10 and +10. I don't have a immediate answer for this. I've had to do things in the past and I've kind of worked around it. What I would recommend is if you need to do this, what can become valuable is I didn't touch on it in this webinar, but this idea of ray selection becomes valuable, where it's more based on selection. It's how the software determines where a mouse is pointing. But it's the same approach as what I expect would work with selecting all the bodies in a given coordinate frame. Okay, and then we have a second question. Is it possible to automate the material assignment and mechanical with or without APDL? I would say APDL. The long and short of it is yes, it is possible. If I was to try to do it initially and I really just wanted to get it to work easily without any issue, right, one option you do have is to, for a given body in SpaceClaim, you can define material properties, right? However, that has to be fully defined to link with mechanical successfully. So that'd be one thing to check. Outside of that, I would have to consider a little more how to automate it fully, because I'm sure there is some scripting that assigns a given material to a body, and you'd want to add that script to your SpaceClaim script so it was fully automated, right? And then as long as all the different material properties were assigned to that body, that will update in SpaceClaim accordingly. For example, here you can see I have sheet metal cold rolled. This was actually brought in because this is what I assigned to the body in SpaceClaim. However, you can note that Poisson's ratio in that given SpaceClaim material is undefined. Therefore, mechanical cannot work with this, right? So that's somewhere where your material in SpaceClaim would just have to be fully defined. Okay. There's another question. Can we create icons with the scripting which can run the entire predefined work? So once again, I have not done this myself, but the long and short answer is yes. Right, there's this tool here where you can publish a script, where then you can create an icon where you just can hit run. Okay. So next question, is it possible to set the unit system at the start of the script, or do we need to convert each dimension we input to inches, for example? So SpaceClaim scripting only is by default meters, right? So when you're inputting dimensions, there's no way to reset it. It's always going to be meters. But when you're inputting dimensions, the workaround is, for instance, here, rather than inputting a value of 0.0022 for meters, this user chose input capital M 2.2, right? And this essentially tells the script, this is a millimeter unit, so it's 2.2 millimeters, not 2.2 meters. You could do the same thing if I want to do inches. This would be inches, IN instead. But by default, and there's no way to change it, unfortunately, the script editor is going to be in meters if you don't assign specific units like is shown here. Okay. Next question. Can you transfer models created with ANSYS and set up with parameters to SpaceClaim to further parameterize? Can you transfer models created within ANSYS and set up with parameters to SpaceClaim to further parameterize? I'm not fully understanding this question, so if you want to elaborate on it, I'll come back to it. Okay, and then let's see. We got a couple minutes, so I'm just going to wrap up with 2 more questions here. Okay, actually 1 more question. In Jaiping, I will say I agree, and I've actually asked SpaceClaim the same thing, so I think they should be working on it. So the last question is, can we run this script directly from Workbench, from the Workbench run script option? I am uncertain. I expect likely not, as it's kind of separate from, actually no, you should be able to. I actually have done this with a separate script where we essentially have used the Workbench run script option and just inserted the respective script to have it generate the CAD automatically, kind of in the background in SpaceClaim rather than opening SpaceClaim, generating the CAD, and then updating. The script there just kind of sends the script to the SpaceClaim executable, creates the CAD, and brings it back without all the associated visuals. So I think there I'm going to have to wrap up since I'm 2 minutes over time. Feel free, if you have more questions, you can send them our way. But I just want to say thank you for everyone attending this webinar. And yeah, have a great Friday.
Yeah, thank you everyone for coming. And again, this recording will be available. Check our website at mallet.com in a couple of days, and it should be available for rebroadcast. Have a good weekend.